Universe, I'm AG, and in Unit 3 we are going to learn about functions. A function takes any value from a set as an input and gives back an output value after make multiple operations. By example, in this function we take each natural number, raises it to the square and gives back the result. The input set is the domain and the results are the range. For scientists, it's not practical to make the operations results for every function, so that's why usually we associate a function with its graph, where the input set goes on the x-axis and the output set on the y-axis. By example, having -2 as input in this function, the output will always be positive, and in this function -2 will give -8 as output. So this gives us an image of the function behavior. In fact, each result is called the image of f or g on x. Now, in the same way like a composite relation, there are composite functions where the output will result after multiple stages. In this example, we have a polynomial operation, and after its result is multiplied by -1. Now, an easy way to have an idea of this function behavior is finding the points where the function line intersects the two axes, and after that give some points and have the complete graph. We know that where x equals to 0 the line intersects the y-axis, and where y equals to 0 the line intersects x. So let's start from here. To find the line intersection with y, replace the x values with 0. And find that the function line intersects on y equals to -3. For the line intersection with x, replace y values with 0. In this case, we rely on the quadratic equation to find any possible solution to the expression. After replacing the values a, b, and c, we found that this equation cannot be resolved, so we conclude that the function never will intersect the x-axis. So, we know so far that the function line intersects y on -3 and never will intersect x, so that's why the line will be located in this region. We give some values close to the intersection and there is the line. So, what about this line? We conclude that this composite function will take huge negative values for any set element, and have this whole picture is extremely useful when we are building complex solutions. Now, if each input gives different results, it is said that it's an one-to-one function, like this for example. If each input gives at least one result, it is said that it's an one-to function. Notice that can be elements without image in the first condition, but in the second, everything has image. The important thing here is, if the function satisfies the two conditions, can be reversible, like this. We can have reversed arrows for each element here. There is a result and vice versa. But this cannot be reversed because 3 doesn't produce any output. The reversible variations in the relations are called permutations. In this example, we have many permutations between the domain and the range, as much as n factorial. We are going to explain in detail the factorial function later. For now, think about it as a number. This represents the number of permutations in a function. For a reversible function with 6 elements, we have 720 different possible combinations. Let's introduce some mathematical functions. Floor and ceiling are used to round numbers with fractional parts, like this by example. floor will output the integer number less than the input, and ceiling the greater integer number than the input. Mark as true or false the following outputs. The integer and the absolute value functions also are widely used in math. The integer removes the fractional part of a number, and whatever be the input, the absolute value will output the positive version of it. So having these three expressions give the output for each input. An extremely important mathematical function in computer science is the remainder, also known as the module of a and b. And this will take two numbers as input and give another integer as output, according to these rules. For now, we will input only integers different from 0. Let's remember what is a multiple. Is any number who contains exactly one or multiple quantities of another number. By example, 10 is a 5 multiple and contains two 5 quantities, but 5 is not a 10 multiple because 10 is not contained in 5. So, if a is a b multiple, then the module of a and b gives 0 as output. By example, the module of 10 and 5 is 0. The module of 35 and 7 is 0. If a is not a b multiple, then the module will take the difference to the nearest lower b multiple. By example, the module of 20 and 7 gives 6. That is the difference between 20 and the nearest 7 multiple, that is 14. In that way, the module of 12 and 5 is 2, the module of 25 and 7 is 4, the module of 3 and 2 is 1. The sign of the b term is not relevant, the output will always hold the a sign. In that way, the module of minus 3 and minus 2 is minus 1, the module of minus 3 and positive 2 is minus 1 again. And if b is greater than a, then the output will be a. In that way, the module of 0 and 2 will be 0, the module of 36 and 40 will be 36, but the module of 40 and 36 is 4. That is the difference between 40 and the nearest 36 multiple, that is 36 itself. Now, given each input a and b on the module function, get the right output and mark the rule that has been applied. Remember that there are 5 rules that we already discussed. The exponential and logarithmic functions are widely used in computer science. Let's see. From now on, we will refer to an operation involving any power as the p or w of x. Also, by the exponential properties, any root can be expressed like this, swapping the indexes. The square root function is null at this point, and the logarithmic functions represent the number that a must be raised to obtain b. These two functions are closely related to its graph, and later we are going to see why they are so important to tell the performance of a computer program. For now, this has been all for today. Thank you very much for watching our video and see you next time.